All right, with the definition of combination as several examples covered, now we're ready to talk about the properties of combinations. At the top, we show you the combination, the choose function, and the math expression. And we have a few properties to go over. The first one, I guess, is overall straightforward. And you can show it mathematically using the definition, but also intuitively, okay? So the first one, as we know, is choosing one object out of n objects. And well, intuitively, you know that there are n different objects and you're choosing one of them. So there should be n different ways to do it, right? And then if you try to show it, I'm just going to do the demo for this one. It's going to be n factorial, right? Over n minus 1 factorial and 1 factorial, okay? And that 1 factorial is 1, so we don't have to consider it. And then this n factorial divided by n minus 1 factorial, the top is really n times n minus 1 factorial based on the definition of n factorial. So the second term get canceled out with the bottom, so you're left with n, okay? The second one over here is really similar to what we saw before is, remember we have seen the case of choosing 0 objects, right, out of n objects, and we know there's only one way you can choose none of them, so it's going to be 1. And this is similar. If you choose n objects out of n objects, you only have one way to do it, and so I will leave it to you to do the mathematical derivation to show that it's 1. But I want to highlight that intuitively also makes sense because there's only one way to choose all of them, because it's to choose all of them. Okay. Okay, good. The second property is pretty important, and I was mentioning it a little bit when we were dealing with the marble examples, if you remember. So this is the left-hand side is saying that I'm choosing r objects out of n objects, right? And then that's the number of ways to do that, the number of combinations there. And then on the right-hand side, in words, what we're doing is that we're choosing n minus r objects out of n objects, okay? So we're saying that they're equivalent, okay? So let's see why. Let's do it mathematically first. On the right-hand side, following this, we know that it's gonna be n factorial divided by, so here is, I have to do n minus r factorial, okay, the whole thing. And then I have my n minus r factorial, okay? So we can further simplify this, as you can see, because once I expand this, it actually becomes r factorial, okay? And it's n minus r factorial, okay? And well, they're the same with each other, right? If I look at this way, just switch the order in the denominator, okay? So mathematically, we have seen that why this is the case. And now let's look or think a little bit more creatively of why they equal to each other. In the marble case, if you remember, we have 4 marbles, 2 red and 2 blue, and we're saying that we're trying to arrange them, right? And then I was saying, the choosing the 2 places for the red is equivalent to choosing the 2 places for the blue, okay? So this is the same reasoning here. If my goal is to choose r objects out of n, it is equivalent to choose the n minus r objects not to be selected. Okay, so left-hand side is that I'm choosing the r to be selected, and right-hand side is that I'm choosing the n minus r to be not selected, but then they should give me the equivalent number of scenarios or number of combinations I can do. Okay, so that's why they're equivalent to each other. So make sure that you know how to do it mathematically as well as intuitively. The last one is really interesting, and take a moment to try to figure it out first before proceed with the video. So the left-hand side of the third one is, well, again, we're choosing our objects out of n, right? And the right-hand side, I should say, very interestingly, right, they break into 2 and then you add them up. Okay? In what scenario do you think that this would make sense? Well, I guess mathematically, and I will leave that to you to do the derivation to verify that the left-hand side equals to the right-hand side. But for the video, for the lecture itself, let's focus on why this is the case. In what kind of scenario that we can actually explain this without doing the mathematical derivation. Okay, so I think it is pretty interesting that you break it into 2 cases and you add them up. And the way to think about it, so again, we have n objects, right? Let me just use those circles to represent them, okay? The right-hand side is saying that I'm choosing r out of the n, and that's the number of combinations, okay? And we don't care about the order, okay, because it's combinations. So to understand why the right-hand side, or what the right-hand side is, one way to think about it is, okay, let me focus on the first object. I'm just going to cross it just to as a highlight here, okay? So in order to choose R objects out of the N objects, if I focus on the first item, there are only two scenarios that might arise. The first type is that, well, in my selection of R objects, the first item is not in there. And then the second scenario is that, well, in my selection of R objects, the first object is in that, okay? So the two are, I should say, cannot happen at the same time, right? When you do a selection of R objects, you cannot have the first item and at the same time do not have the first item. So they are, later we're gonna term this complementary to each other. These two events are complementary to each other. But at this point, right now, we're just going to focus on how many ways we can achieve the first scenario and then how many ways we can achieve the second scenario. And then we're going to add them up because each of these scenarios is going to achieve the task of choosing R objects out of N. Okay, so the left-hand side, sorry, the right-hand side, let's look at the first term. The first term is actually mimicking the scenario that we're talking about, that the first item is not being selected. Okay, to see why, you see that we're choosing R objects, right? And we're choosing from the N-1. So this choose function is, like I said, mimicking the scenario where we do not select the first item, okay? Because we're choosing all of the R objects from the remaining N-1. The second term, the choose function here, is mimicking the scenario of what we were talking about earlier, that the first one is being selected already, and then we need to choose the remaining R-1, and the pool that we're able to choose this from is the N-1 remaining objects that we have not considered yet. Okay, so these are really two events, or I should say two scenarios that cannot happen at the same time, but each of them achieves the final task of choosing R objects out of N. So we add them up, and then this is why the left-hand side equals to the right-hand side. And in fact, this result goes to applies to any particular choice that you're any particular item that you focus on. I was just using the example of the first, but you can also consider the second and the third. If you only focus one of them, the right-hand side makes sense, and then equals to the left-hand side. Okay, so the properties of the combinations are pretty important. Some of them, as you can see, very intuitive. Some of them might not be at the first glance, but after some reasoning, it becomes clear, so that would be good. And then, of course, many of these results will be really useful later on when you're solving exercise questions.